All right, next up we have Dariusz Lacheta. Hello.
Hello, nice to be here with you all.
Great to have you. So tell us a little bit about yourself.
I am a 3D generalist from Poland. I have almost 12 years experience, mostly in TV commercials, motion design, some in game art for indie games. And mostly I was freelance artist, but sometimes also work in the full-time job in small studios.
Awesome. So what are you going to be talking about today?
Today I will be talk about two my entries from Mardini. One is little castle on the mountain, and second running river with a flip simulation.
Awesome. Well, let's jump in.
Okay.
Okay guys, I will show you a quick breakdown of this simple scene. As you can see, it's nothing special. In dailies you have a couple of hours at the most to make something like that, so done is better than perfect. Okay, so this is how it looks in Houdini. As you can see, very simple. Tower hovering over the ground and whatnot, but it looks okay from the camera. And this is how my scene is organized. We'll start from the ground, from the mountain, and what I did is create a high field with a simple high field noise, and here is very simple, just played with amplitude, element size, a little bit of offset here and there, until I had something that will closely work what I had in mind. So it's some kind of hill, and after that I use a road, high field, almost default values or very little changed. This is very important to not leave your timeline in very far, because it take quite a bit of time. Like you can see, it's quite time to bake. And after that I converted into mesh and use file cache. As you can see, this is what I got, and it was almost what I wanted. So I used edit node to, as you can see, make it more flat here where the castle will be. So it's simple, just select some points, move it with soft selection here, so you can make soft changes to broader area. And here's material and out. Okay. So about rocks, it's very simple. Like in 50 Houdini tutorials, I use a simple sphere with mountain, and that's pretty much it. For the distribution plane, I imported the whole mountain, then reduced it to simpler geometry. It could take some time, so I will stop it. Then I blasted it and cached. So what I have here is just something that will be visible from camera. As you can see, this is the camera movement. So I selected faces from the camera in the first frame, like so, and then add selection in the last frame and blasted. So I only will have a distribution of plants and rocks where camera will see it. Then I used scatter and align, a very handy little node, and probably only used rotation and maybe max radius, something like that. And here copy the points, and you have your rocks with different scale, material and out. Okay, and here's a little more complicated thing, castle. So also quite simple. First I sketched walls from the top where I wanted to have the walls. Then from the perspective and camera, I moved a little higher on the ground, resample it and extrude it. This is very important to extrude inwards. So I have this strip of polygons, and here I use group by range to select every other polygons. As you can see, you can have every third, fourth, and so on. And I used this group to poly extrude. As you can see, it is affected only by this group to create this top stones on the wall, and standard poly extrude to create wall itself. Very important is not to output back, so I have this little gap here, and after reverse normals, I could merge both meshes and I have a full wall. Then fuse points, create a simple UV based on the cylinder, and that's pretty much it for walls. And very similar situation for tower. As you can see, I started from the circle, translated and resample like wall, and poly extruded. All the same, create every other group, extruded that and a wall itself, create normals, reverse, merge, fuse, and I have a simple tower. And here I used a resampled curve to create points that will be used to create windows in the tower. So here is, based on this resample node, I will create how many windows will be in the tower. So with every point will be another window. And I use a box here, very long box, to copy 2 points on that curve, as you can see. And as you can see, if I change the number of points of the curve, it will change number of windows. And here is simple Boolean operation that will subtract that boxes from tower. And of course, simple UV project cylindrical shapes, and pretty much that's it. And I have tower here. And here I use transform to create a copy of the tower upstream, so, and move it to the different position. So as you can see, there is different towers in different places based on camera. And here I merged every tower and walls together in one place and give one material. And that's pretty much it. A little interesting is a flag. Also quite simple, but I created simple grid. As you can see, it's quite dense. And here, Velum constraint is almost everything by default. What I really changed is here, pin to points. When you do something like that, and I select some points, in the simulation, this point will be pinned in place and everything else will be moved. And in the solver, volume solver itself, I only changed wind, 15 units here. And that's pretty much it. And what else I use, 100 frames of animation, but simulated, as you can see, 200 and cached 200 frames. That's why here in the after the simulation, after loading from disk, I can use retime node and use this 200 frame sequence to use only in the part of it. So here from frame 100 to 200 in this object, and here it's similar situation, but from the frame 150 to frame 50 to 150, and so on for the other flag. And simple tube moved in the place as the pole from the flag. That's it, pretty much. And I had 3 different flags with the same simulation, but offset a little bit. And as you can see, you can really say it's the same flag. It looks like the wind is affecting the same way, because wind is affecting the whole scene, but every flag will look different, and you had to simulate only one of them. Okay, and now we'll go to the tree. Exactly, not really tree, but branch, not branch, but bushes. What I wanted to do, and I used here ZFX Labs tree generator. So I will start with very simple and low poly trunk, as you can see, and only thing I changed is resolution, make it very coarse and lightweight, a little bit of radius, and as you can see it's length, and pretty much that's it for the trunk. And here is 2 levels of also very low poly branches. As you can see, also I'll change resolution and a little bit here in general section, like radius and number of branches. Here is another level of branches, very simple, very I could say ugly, but it's good enough for what I wanted to do. And here is a simple 3 leaf shape, also from ZFX Labs. As you can see, very low poly, like from game, but with enough of them and far away from camera, it's more than enough. And here 3 leaf generator that uses branches from the upstream, and leaf here to distribute the leaf around the branches, as you can see. And it looks pretty nice for all the time I spent on it, so like 15 minutes at max, probably even less so. And here is material, one material of bark from Megascan to everything, and using group from the leaf above to create a very simple, probably with just 1 color material from the all. And here I cached, just in case, this branch, so as you can see, it's a little bit different after our modification here. And that's it for the tree. And here is tree distribution, very similar to the stones. Import the whole mountain, reduce it, blast, and you have only the part that is visible to the camera. So yeah, this is probably the same file. And here I used simple scatter, not this new node scatter and line. This was more than enough for my purpose. And First, I used a box to visualize how this will look, and will be very lightweight. And here I create a node attribute randomize. It could be done in different ways in Vex or different nodes, but this will create attribute and also randomize values between every point. So here I use p-scale to, as you can see, change the scale of the bushes around all the points. And here is orientation. So not everyone will face the same direction. And very important, orientation is not tree, not rotation, just orientation, so it's 4-dimensional. And here is up vector. It doesn't do anything, guys. Okay. And this is quite important. I use Redshift to render, and when I use copy to points and render from this node, it seems that Redshift use every geometry translated, and it's very heavy on the render. So this is good for previewing and seeing how it look in the scene, but to render I use attribute of wrangle that uses that point, and it have very simple little code as at instance equals, and this is name of the tree. In our cases, it's really the bush. So to make changes between what is will be rendered and what is displayed, if you hold Ctrl and click on the display flag, it will be purple, and this will be rendered, and this will be displayed in the viewport. Okay, and last thing is a grass patch. And what I did here, it's also like everything else, very simple. I started with line, just a couple points, then bend it a little bit, and use polywire just to create very simple geometry. Very low poly, but with enough of the grass strands, it will add up really quickly. And here, for distribution of the patch, I will use tube. Then I delete everything except top part, remesh it, so I have more points here and quite even distribution of them. Move it to the origin, and here I created text to attribute create node attribute density, and add value of 0 to every point of this this plane. And here I created a sphere, make it smaller, and move it, as you can see, in the middle of the patch. Just it barely touches the geometry itself. And here I created also a density attribute, but with value of 1. And here is magic happens. So attribute transfer. This one will transfer attribute of value of 1 from the sphere to everything else, and it will be gradually translating from 1 here to 0 on the very edge of this plane. And this blend of width is where you control how much this will occur. So this is scatter node that, as you can see, density attribute is set here, and there is more points in the middle and fewer outside. And as you can see, when I change blend width, it will change how it's behave. Okay, and here is very similar normal. Okay, I didn't need to create attribute randomize to add normal, but this is what I did. P-scale is pretty basic, and up vector. and copy to points. As you can see, create all the strands of the grass in the one big patch. And it's a little bit color randomized to visualize all the strands. It's quite a bit of them. Simple material, and that's pretty much it. And here is almost the same setup as from the bushes. So here is I only imported reduced geometry visible from the camera, sculpted it a little bit, scattered the point, added p-scale attribute, up vector, and that's it. And here I only use even in the viewport this node that will show basically only points, but will render just fine with Redshift, because when I use this patch of grass and copy to all the points, as you can see, there's a lot of them and it's extremely heavy. So it's better to use something like box or something very lightweight to visualize how it looks, and just use this little trick with attribute wrangle to render. And that's pretty much it. About all other scenes, it's just a simple dome light with HDRI and sun. As you can see, it's very simple. All the color correction and post-production and whatnot, it was done here in the basic Redshift controls. So as you can see, it's quite a fast render. I have a lot photographic exposure, very simple, little bit of gloom, and heavy bokeh with peak radius and power, because the scale of the scene is huge. And that's pretty much it. Thank you for watching.